Welcome to your online source for calculator tutorials. In this tutorial, we will learn how to use spacetime to calculate intersections, maxima and minima of multiple functions. Begin a new spacetime document so that your screen looks like mine. We will start by creating a list of 3 functions to plot. Remember to use brackets when creating a list. We want to plot x squared. Separated with a comma for our next function, we'll look at 5x minus x squared. And then our last function, we'll look at a linear function, 2x minus 3. So we have our 3 functions. Let's go ahead and hit the plot button. Go ahead and minimize the button pad so we can see everything, and then adjust the style and the colors to your liking. Alright, once all that is done, go ahead and double tap the plot to go in. You'll see across the bottom 4 options: zeros, minima, maxima, and intersections. These are options used to calculate specific points of interest on the graph. Select the zeros checkbox. Notice a group of gray circles. These circles mark the locations of places on the graph where a function crosses the x-axis. There appear to be only 3 circles, but if you notice, the circle in the middle is overlapped as both quadratic functions pass through the origin. The other zeros are x equal to 1.5 and x equal to 5 and are visible when tapped on. Notice you can also tap on the origin one as well to see x equals 0 and y equals 0 for that point. Deselect the zeros checkbox and check the maxima and minima checkboxes. 2 circles appear. These correspond to the maximum of the 5x minus x squared parabola and to the minimum of the x squared parabola. Once again, you can tap on these to reveal the maxima or minima. Finally, deselect the minima and maxima buttons and select the intersections button. At first glance, it appears that only 3 circles show up, but clearly the green function intersects the red function here. This will often happen for points of interest like maxima, minima, and intersections that are on the periphery or on the outside of the viewing area. You can simply move the graph center a little closer to these, and if that doesn't work, sometimes zooming in will get them to appear. So notice that we can zoom in on that point of intersection, but the moment we make it go closer to the edge of the screen, it disappears. In this manner, you can get to all the different points of intersection, and you can tap on each of them quickly to reveal their intersection points. Be careful to remember which points correspond to intersections of which graphs, rather than just recording the points themselves. For instance, it does you no good to record x equals 2.5 and y equals 6.25 unless you know that that's at the intersection of the red parabola and the blue parabola, in this case 5x minus x squared and x squared. This concludes the calculating points of interest on the graph tutorial. Feel free to replay this tutorial or browse any of the other available topics on the course webpage.